In 2012, data scientist was called the sexiest job of the 21st century. Not by me, but by the Harvard Business Review, no less. And in the last decade, data science has experienced a bigger growth in jobs than any other profession, up 650%. But what is data science? My name is Stephen Simpkin, and I've worked in the data analytics team at Essex County Council for 15 years. My background is in statistics and social science, and last year I was given the honour of winning the inaugural Sir Professor Ian Diamond Excellence in Local Government Analysis Award. So as Data Science Fellow at Essex County Council, hopefully I'll be able to answer these questions. Not just what is data science, but also some of the other terms you would have heard with an increasing frequency over the last few years. What is machine learning? And what is artificial intelligence? And lastly, why do you need to know? Now, often these terms conjure up quite flamboyant imagery of crystal balls, self-driving cars, and robots. When in fact, for 99% of the time, it's much less exciting than this. Certainly where the public sector is involved at this point in time. It's mostly people at a desk conducting traditional research and analysis, albeit in a more modernised way to get more value from all sorts of data, processing and analysing in more efficient ways to deploy more real-time intelligence. So let's take a look at an example of any piece of work and focus on what you can do with data. And this should give some clarity to the data science way of working versus traditional research and analysis. Now, everything starts with a problem or a challenge to be solved. And 10 to 15 years ago, it was no different. And this was typically the way traditional research and analysis happened. We'd have our business problem. We then got data from somewhere, and we'd move it into some analytical software and analyze. And finally, we'd make a big report of findings and leave it to gather dust on someone's desk or inbox. Now, the data science process starts in the exact same fashion. We have our business problem. From this point onwards, things are different. So data is not static and it will change. If you take it out of a system, it can immediately become outdated. People age, people move, localities grow, data grows. Typically, end-to-end data science work attempts to access data from source and analysing its source through syntax or code, thus enabling greater automation. Ultimately, being able to push outputs and visualizations into a reporting mechanism like Tableau or Microsoft Power BI. And instead of being separated stages where data is arbitrarily being moved from one place to another, like in the old way of working, in the data science process, this can all be connected. What this means is that we can put real-time data and analysis into the hands of the end users like yourselves. Obviously, a good team won't just dump dashboards or outputs on people and leave them to it. With any analysis, we still need that element of domain expertise to interpret outputs, translate what they mean, and make recommendations for potential actions that can be taken. And in a nutshell, that is the data science process. And the classic Venn diagram that you'll get if you Google what is data science is that triangulation of traditional research and analysis, subject matter expertise and all other sources of intelligence, and programming and good data management. And it's that last component which is the main difference. Being smarter with how data is accessed, processed and productized, creating end-to-end, up-to-date fluid outputs instead of paper reports becoming outdated on desks before anyone has even had the opportunity to take action from the evidence. Now, there is slightly more to it. As well as being more voluminous than ever, and with different types of data accessible, the things people can do with data has also moved forward considerably over the last 10 years. Typically, in the past, analysis mainly operated in these spaces. What has happened? How many things have happened? Why has it happened? That is descriptive and diagnostic. The slight difference being the old ways of working or diagnostic might be in the form of a static report, whereas the data science process can also enable those kind of real-time dashboards. However, the data science process has also enabled more work to happen in this predictive and prescriptive place. So predictive, identifying outcomes before they happen, and prescriptive being knowing what action can be taken that might prevent undesirable outcomes, or which actions will result in positive outcomes. Which brings me nicely to machine learning, a term which I'm sure you have heard. Now, my first venture into building a machine learning algorithm was about 10 years ago, and this was to determine whether we could predict children who were a NEET risk, and that's not in education, employment and training. This is when children finish compulsory education and do not go into employment or further education. Not only is this a less desirable outcome, but there are also significant costs associated. Now, as always, we start with our diagnostic. Everything is based on identifying patterns in historic real-world events and data. So we begin by looking at who becomes NEET, and we can look at literature and intelligence from schools to supplement our data analysis, as well as commissioning intelligence. Now, there are loads of risk and resilience factors which impact individuals' risk of being NEET. I'm going to keep the model simple and just use 3 factors. We know unauthorised absence has a big effect. So as absence increases, NEET risk also does. We know economic disadvantage or deprivation has an impact. That greater financial strain increases that NEET risk. And I'll also include key stage 3 attainment. Now here, my ultimate aim is to look at all children aged 15 and identify those most at risk. To do so, I build my machine learning algorithm on historic events. Children that have already finished compulsory education and have gone on to be NEET or EAT. I can look at their absence up to key stage 3, I can look at their attainment at key stage 3, and their respective deprivation at that point in time. Now this will give me the optimal weighting for how much each of these things increase or decrease NEET risk, and that is my algorithm. I can now apply this to all children who are 15 right now, and next year, and so on. This will highlight the children I could seek to prioritise any interventions towards 3 years before that undesirable outcome happens. This is predictive. Now here is where we operate slightly different in the public sector, and it is entirely by choice. Now we could instruct our model to refine the algorithm every time new data becomes available. So each year, as a new cohort becomes NEET or not, we could build in that new data, and the model weightings would ever so slightly change. Now this is how many private sector organisations operate. For example, mobile phone to churn models. Strictly speaking, that is true machine learning and creates this continuous loop whereby learning happens without any additional programming. Now we currently embrace this human in the loop machine learning, and it's the exact same process except we do not allow that constant automatic loop. Here, analysts take a more hands-on approach to any algorithm refinement and carefully evaluates before accepting any changes and deploying an updated model. So we've covered what data is and what makes a good data project earlier on in these sessions. My colleague Nikki covered what is analytics with the 3 Ps, prioritise, plan and predict. I've just given an overview of data science and machine learning. And just to finish, I'll touch briefly upon artificial intelligence. And I fear the phrase fills decision makers with dread. Or probably not the phrase and just one of those words, artificial. We all want intelligence. The use of the word artificial doesn't diminish the strength of the intelligence at all. Machine learning, and the example I just talked through, is a branch of artificial intelligence. And hopefully you would have seen that it's a combination of real-world events, subject matter expertise, research and literature, and the analytical know-how that all combine to provide the intelligence. And it's not a robot. A nice super summary I found is data science produces insights, machine learning produces predictions, artificial intelligence produces actions. As decision makers, all these things are important to you. At the top, the data science process can help put up-to-date intelligence in the palm of your hands. Machine learning approaches, with our human in the loop, uses all that intelligence to make predictions on what will happen. And as we become more confident in these predictions, we can seek opportunities to find a way of making artificial intelligence work for us. Right now, there are fewer examples of artificial intelligence being driven by the public sector, but that's not to say there won't be some in the near future. This doesn't mean robot counsellors, but it's much simpler applications, some of which already exist. such as assistive technology, recognizing patterns synonymous with a fall and immediately alerting people, or smart home technology that optimizes energy use in homes, or even the push notifications you get on your smartphone. And I will end with this quote from Eric Schmidt, the Google chairman. Google self-driving cars and robots get a lot of the press, but the real future is in machine learning, the technology that enables computers to get smarter and more personal. Thanks for listening.